Okay, here we go with the first topic of topic 3 in the IB Physics curriculum. So this topic is thermal physics, and today we're going to discuss temperature. So we're going to basically talk about temperature and its relation with thermal energy transfer. We're going to talk a little bit about what thermal energy transfer is, and we're going to talk about the temperature scales. So what is temperature? You have experience with temperature in everyday experience. If something's hot, if something's cold, you kind of know what that is. You can feel that on your body. And you know what hot temperature is. 30 degrees Celsius is hot, whereas minus 10 degrees Celsius is cold. And that's all temperature is, just a measure of how hot or cold something is. But we need a way to define it, and we need a way to measure it. For example, the meter is defined as the distance traveled by light in 1/300 millionth of a second. The speed of light is constant, so we're measuring the meter based on that physical constant of nature, which is the speed of light. So we need a way to define temperature in a similar way. And so how can we do that? We can do that by relating the temperature of one object to another object. And that's how thermometers work essentially. So when a thermometer, mercury is in the thermometer, and we know the properties of mercury, and so we use that as a scale. And if we place that mercury in something, for example, a cup of coffee, then we can relate the two, and we can relate what the temperature reads in the mercury thermometer versus a coffee cup. Okay. Another way to do to find temperature is, for example, the freezing point of water, which is 0 degrees Celsius, and that's how the temperature scales are actually defined. But basically, what we need to do is compare the temperature of one object to another known object. Okay, and what we find is that they reach an equilibrium. They reach the same temperature. And so what's happening there is basically thermal energy is traveling from one body to another. So thermal energy is the energy transferred and energy associated, with the body's temperature. So another word for that is heat, and we're going to talk about that a bit in the next topic, but it's basically how much energy is passed down to an object. Okay, and they're going to reach something called thermal equilibrium. So if we have two objects exactly the same in all of their properties, okay, they don't look the same there, but it's because I'm not a super drawer or super artist. So this one is at 5 degrees Celsius, and this one is at 55 degrees Celsius. And we smush them together. What we're going to do is put them both together, okay, and see what happens to the overall temperature of the two. Okay, well, what's going to happen is if they both have the same properties, they're going to reach an equilibrium. And that equilibrium means they're both going to have the same temperature. Okay, that's 30 degrees Celsius. And that is what thermal equilibrium is. So thermal equilibrium is when two objects are at the same temperature. Now, the example I gave before about a thermometer, if we put a thermometer, for example, in this, which is 55 degrees Celsius, okay, this is going to give up some of its heat to the thermometer. But when they reach an equilibrium, that's when we can read the temperature. And that's why you see the mercury rising as temperature raises. But when it stops, that's thermal equilibrium, and that's the final temperature of this body. Okay? So temperature scales. There's a number of different temperature scales we use. The Celsius scale, which is named after the scientist Andreas Celsius. There's the Kelvin scale, named after Lord Kelvin. Both scientists who did a lot of work with temperature. There's Fahrenheit scale, the Rømer scale, the Delisle scale. So there's lots of different scales. The ones we use are the Celsius scale and the Kelvin scale. And what we need to do basically is find a way to relate them. Now, both of them use this right here. That's the freezing point of water. And not both scales. The Celsius scale uses this as a reference point. Okay? And the Kelvin scale and the Celsius scale both have the same number of divisions. Okay? So each of these divisions is exactly the same as Celsius and Kelvin, which allows us to make a very simple relation between the two. Temperature in degrees Celsius is temperature in Kelvin minus 273. Okay, so let's try an example. So if the temperature in Miami, Florida is 25 degrees Celsius, which is a lot nicer than it is here right now, what is the temperature in Kelvin? So we want to find the temperature in Kelvin, given that we know, so this is an example, the temperature in degrees Celsius is 25 degrees Celsius. We want to find the temperature in Kelvin. Well, if we rearrange this equation, it's temperature in Kelvin equals temperature in Celsius, and move this over, plus 273, that's 25, plus 273, this gives us 298 Kelvin. Okay, so pretty standard calculation there, but it's important to know how to do that calculation, to make that conversion, because sometimes we may have to move between one scale and the other scale. Okay, so temperature and thermal equilibrium, we're going to come back to this now, because this is a important property. So the two can be used to basically define each other. Temperature can be used to define thermal equilibrium, and thermal equilibrium, same with temperature. But let's say we have three objects. So we have A, B, and C. Okay, what we have is if these two objects are in thermal equilibrium, okay, if A and B are in thermal equilibrium and B and C are in thermal equilibrium, that means that A and C are also in thermal equilibrium. This is what's called the transitive property. Okay, and it might be familiar to you in mathematics, where they have two things on either side of an equal sign are exactly the same. So 1 over 2 is the same as 2 over 4, which is the same as 4 over 8. Okay, so they all equal each other. Okay, and this is what's known as the zeroth law of thermodynamics. So if two thermodynamic systems are each in thermal equilibrium with a third, so these two are both in equilibrium with this guy, then all three are in thermal equilibrium with each other. Now this is called the zeroth law, because before this they had made the first and second laws, and they came up with this law. Instead of calling it the third law, they called it the zeroth law, because they decided that it was more fundamental and more important than the first two. Not more important, wrong word there, but it was more fundamental, and the next two laws kind of relied on this law. Okay, so that's the zeroth law of thermodynamics, and it's really important. So this is temperature, thermal equilibrium, kind of relating the two. So this is all you need to know for this topic. Next, we're going to discuss heat, so how temperature changes, and internal energy, so the temperature that's contained within a body just like this, B. Alright, thanks for listening.